So, welcome next lecture of MAT-401, that is numerical analysis. So, in this lecture, we'll see third method to solve ordinary differential equation. It is Euler's method. So, first we'll explain what is Euler's method, and then we'll solve one illustrative problem on it. So, consider the differential equation dy by dx equal to f of xy with initial conditions y of x0 equal to y0. B initial value problem. So, already we have seen it. So this problem is called initial value problem. So we solve this initial value problem using Euler's method. Suppose that, so we want to solve the differential equation for, yeah, for values of y at x equal to x0, x equal to xr, where xr is equal to x0 plus rh. So here we'll take h, which is the common difference between two consecutive xi's. So let us take xr equal to suppose x0 plus rh. So x0, that is first value of x, then x1. So what will be x1? So x1 will be x0 plus h, then x2 will be x0 plus 2h, and likewise, so xr will be, that is x0 plus rh. So we want to solve the differential equation for values of y at x equal to x0 plus rh means at xr. That is what we find. So integrating the differential equation dy by dx equal to f of xy from x0 to x with respect to x. So we can write this integration from y0 to y0 to y1 dy. So here we integrate in the interval x0 to x1, then x1 to x2, x2 to x3, x3 to x4, x4 to x5, and likewise. So first integration from x0 to y0 to y1 dy. So here you have to integrate from x0 to x1 f of xy dx. So here limits of y are y0 to y1, limits of x are x0 to x1. So after integrating, so integration of dy will be y. So you'll get y. Integration of dy is y, and limits from y0 to y1. So it will be y0 minus y1. Sorry, it will be y1 minus y0. So you can transfer this y0 to right hand side. So you'll get y1 equal to y0 plus integration from x0 to x1 f of xy dx. So that will be the resulting equation. So you can call this equation as equation number 1 or just as it is. So assuming that, suppose f of xy is equal to f of x0 y0 in the interval x0 to x1. So this interval x0 to x1, let us assume that that function is constant and it takes the constant value f of x0 y0. So we get, so substitute the value of f of xy in the interval x0 to x1, that is f of x0 y0, which is constant. So resulting equation 1 will be, so it will give us y1 equal to y0 plus integration from x0 to x1. The value of f of xy is f of x0 y0 dx. So you can take this constant value f of x0 y0 outside of this integration. So it will be y0 plus f of x0 y0 integration of dx, and that will be just x, and limits from x0 to x1. So you'll write it as y0 plus value of this integration will be x1 minus x0 into f of x0 y0. But x1 minus x0 is nothing but h, because we have x1 is equal to x0 plus h. So naturally x1 minus x0 is h. So you will get y1 is equal to y0 plus h into f of x0 y0. So you can call this equation as equation number 1 or equation number 2, whatever it is. So don't call this equation as equation number 1. Yeah. So let's call this equation y1 equal to y0 plus h times f of x0 y0 as equation number 1. So similarly for the range x1 to x2, means if x lies between x1 and x2, so you'll find, so using same procedure which we have seen for y1, so you'll get y2 is equal to y1 plus h times f of x1 y1. So proceeding in this way, so you can call this equation as equation number 2. So proceeding in this way, so we obtain general formula, That is yn plus 1 will be yn times yn plus h times f of x and yn. So here n varies from 0, 1 to it goes to infinity. So for n equal to 0, you will get y1, that is y0 plus h times f of x0 y0. That is our equation number 1. For n equal to 1, you will get y2 is equal to y1 plus h times f of x1 y1. That is your second equation, and likewise. So this is the required Euler's formula to solve ordinary differential equation or initial value problem. So next we will see one illustrative problem, and then we will stop. So using Euler's method, find y of 0.02 for the differential equation y dash equal to minus 1. So y dash means dy by dx. So dy by dx equal to minus 1 with the initial condition y0 equal to 1. So here f of xy is equal to minus 1, x0 is equal to 0, and y0 is equal to 1. So consider, so h equal to 0.01. So how to choose this h? That depends on which value you have to find. So here you have to find y of 0.02. So that for that you have to choose that h. So that, so from, and what is x0? So x0 is h. So you have to start from 0 and you have to reach up to 0.02. So for that you have to choose h. So what is x1? Say x0 is equal to 0 here, h is equal to suppose 0.01, then what will be x1? So x1 will be 0 plus 0.01, so that will be just 0.01. Similarly x2 will be, that is x1 plus h, it will be 0.01 plus 0.01, so that will be 0.02. So at x2 you have to find value of y. So what is your objective here? So you have to find y of x2, means you have to find y2. So the value of y2 we have to find. So we have y1 equal to y0 plus h times f of x0 y0. So this is from Euler's method. So it will be y0 plus h times f of x0 y0 is minus y0, because f of xy is given and that is minus 1. So you get y0 plus h times minus y0. So let us put the value of y0 and h. So you'll get, it is 1 minus 0.01 into 1. So it will be 0.99. So y1 will be equal to, see, y1 is equal to 0.01, and this is nothing but y at 0.01. y1 means y at x1. Similarly, using Euler's formula, so let's put n equal to 1 in Euler's formula, you will get y2 is equal to y1 plus h times f of x1 y1, that is equal to y1 plus h times minus y1. So let us put values of y1 and h. We will get y of 0.02 equal to 0.99, that is value of y1, plus 0.01, that is h, into value of y1, that is minus 0.99, and you will get the value of y at 0.02 equal to 0.9801. So this is the required solution or required answer of this differential equation. So here is one homework, so which you can solve. So same differential equation, same initial problem is there. Just you have to find y at 0.03 and y at 0.04 in previous example. Means you have to find. So here x0 is equal to 0, x1 is equal to 0.01, x2 will be equal to 0.02. Similarly, x3 will be equal to, so x3 will be 0.03 and x4 will be equal to, that is 0.04. So you have to find y at x3 and y at x4, means you have to find. So you have to find y at 0.03, means you have to find y3, and y at 0.04 means you have to find y4. So same initial problem is there, but just you have to find two more values of 1, and it is as homework. So this is Euler's method. So I will stop here.